Alright, now collectively I'm going to give you bits and pieces of the unit circle, some of the information, and we're going to break it apart, and then eventually we're going to bring it together as a whole picture. But when we're asked to find exact values of trig functions of like a 45-degree angle, and I tell you some special numbers to remember when we have these values, I don't want you to feel like I'm just pulling them out of anywhere, so out of nowhere. I'm going to take a few minutes and say, well, where does this come from? So first of all, if I take a circle, and the definition of a circle by the formula is x squared plus y squared is equal to the radius squared. Now, in a unit circle, what's our radius? 1. So this equation represents our circle. If I drew a dotted line right here, this is our equation y equals x. This is just thinking back to algebra. Y equals x where the slope is just 1. Now, if I dotted this line right here, and I said, oh, you know what? I know that this is 90 degrees. What's halfway in between? 45 degrees. So I'm okay with that. So if I know that y is equal to x, I can come and in place of y, I can substitute x. Now, 1x squared plus 1x squared is 2x squared equals 1. Divide both sides by 2 and then take the square root. I simplify this, and when I rationalize the denominator, I find out that the x value is square root of 2 over 2. If x is square root of 2 over 2, then y is square root of 2 over 2. So when I later give you your unit circle and we say 45 degrees, the point associated with that is square root of 2 over 2, comma, square root of 2 over 2. That's exactly why. That's where these values right here came from. Okay, knowing that information, we're now going to use our 6 trig functions. Sine of 45 degrees. Your sine is going to be your y value. What's the y value? Square root of 2 over 2. Sine of 45, square root of 2 over 2. Cosine of 45 is going to be your x value. The x value at this point is square root of 2 over 2. Tangent, by your definition, is your y over your x. Okay, so y over x would be this value divided by this value, which you can see it represented here. It's the same thing divided by the same thing, which just simplifies to 1. Easy simplification there. Cosecant is going to be 1 over y. So here's my 1 over the y value. Algebraically, we would simplify and we get square root of 2. Secant of 45 is going to be 1 over the x value, simplify, square root of 2. Cotangent is your x value divided by your y value, simplifies to 1. So that's where those values come from. And we'll do this one. Let's look at a few examples. Actually, we're going to hold off on some examples. Let's go ahead and do the 30 degrees and the 60 degrees as well. Okay, just like with 45, I told you where things come from. You won't have to memorize these, but when I give you special numbers, when I tell you that this triangle, this rectangle over here, has the side 1, square root of 3 over 2, 1/2, I want you to feel comfortable in knowing where it came from. So let me just take a side note and say, if I took this 30, 60, 90 triangle right here, I know this is 90 degrees, and all of a triangle is going to be 180. I mirrored it and put a reflection of it over here on this other side, flipped it over, and drew a dotted line and told you that this was an equilateral triangle. Equilateral meaning all sides equal. Side is 1, side is 1. What would that make this side right here? 1. Very good. So when they say 2a is equal to 1, 1a plus another a is 2a is equal to the side that's length 1. That's where they would get this value, a is 1/2. Okay, so we're okay with that. Now, if I covered this back up, ignore this piece over here, and just look at this triangle with me. I have a triangle. I know a side 1 here, 1/2 here. How could I find a missing side? When you have a triangle, and you have two sides that are given and one that's missing, what have we used in algebra? Pythagorean theorem. So we jump back in and we use Pythagorean theorem to figure out that the missing side is square root of 3 over 2. So just in a nutshell, where I'm getting these values from, those are the calculations for where they come from. You in Trig just need to know how to use them. Okay, so now we're going to use them. I tell you the point associated with 60 degrees is this point right here. Okay, derived by the triangle, the rectangle, triangle, I keep calling it rectangle, the triangle are going to be these values. So here's our x value, here's our y value. Now let's apply trig. Sine of 60 degrees, the sine is your y value. So what's the y value? Square root of 3 over 2. What is the cosine? The x value at that point, 1 over 2. The cosecant is going to be your 1 over your y value. So 1 over the y value. Algebraically, you simplify, and we would get 2 square root of 3 over 3. Secant is going to be your 1 over your x. 1 over the x value simplifies to 2. Tangent is going to be your y over your x. So we take our y value, put it over our x value, and you algebraically simplify to this. And then cotangent, you're going to have your x over your y. So we have our x value over our y value. Algebraically simplify, and we get this. Okay, and the next one is of a 30-degree angle. So we did sine, cosine, tangent, all 6 of the trig functions using the 30-degree angle, where we put the triangle in here. The corresponding point is here. So I'm just going to pause it, and you can take a minute to go around and calculate those values. And then the past 2 slides were basically deriving this table, and so all of those values are now listed in the table.